Alright, this video will show you how to do interpolated stimulus in Altia design. What I mean by interpolated stimulus is just like with animation in previous videos, you can define a start state and an end state, and Altia design will figure the rest out for you. Now, the benefit of interpolated stimulus is it provides things such as motion tracking for sliders, and that's what we'll make today. The way this works is just like with animation. You define a start state motion track point and an end state motion track point, and it figures out the stuff in between when you're moving your mouse left to right on a slider, for example. Now, to give us something to stimulate, and for just a little review, I go slower in previous videos talking about animation, but never hurts to review, and we do need something to stimulate here. I'll go ahead and actually draw up a quick slider, just real basic slider here. I begin by drawing the track, or the base. Base, track, slot, whichever term suits you best for a slider. I'll just call this track vector, and I name it vector because I'm going to group that, and maybe just if I ever wanted to replace the track with an image instead of a vector, I could do that. And then I'll just draw what looks like a nice handle, and group that, of course, because I'm going to animate it. So I'll just call this handle. Whoops. Handle there. Alright, and I'm going to animate this object, but before I do that, I just want to make sure positions are okay. So what I'll do is I'll make sure that align left edge are matched up and align vertical centers are set up, and that looks pretty good there. And maybe I'll change the color of the handle just so it's, you know, different from the track. That looks pretty good there. Again, the artwork here is, and the point is to learn how to do interpolated stimulus. So it doesn't have to look gorgeous, it just needs to do what we expect animation and stimulus wise. Now, this is the beginning of a slider because we have these shapes, but we don't have anything animating, so that if we were to track motion, you wouldn't see anything on the screen. So just a quick review on how to create animation. I'll just enter a new animation called slide, tab, space, grab it, and grab the handle and move it to the side here. And I'm holding down control to limit motion to the x-axis here, and I'll just let go where it looks like it's the other edge. I could use a line, but don't have to be too perfect here. And what I'm going to do there is just type 100, hit define, select the animation in my animation pane and test it, and sure enough that works. Okay, so we've now given it the ability to visually animate as a slider, but if I were to put this in run mode, you can see absolutely nothing happens. So let's fix that. Let's put stimulus on this slider and make it able to track motion back and forth. The very first thing we have to do here is create a rectangular region, and the rectangular region type is going to be enter. And we want something that is fairly well as tall as the slider handle, and I could select the handle and see, okay, you know, that's about 150 pixels tall. But we want to make sure that when we're creating the stimulus, you have the part that's not moving, that is not the handle that's moving. And this really applies to any interpolated stimulus. If you're going to track motion, track it on something that doesn't move. Otherwise, you're tracking motion on a moving target, and that can cause problems. So I'm making sure I have the back object here selected. I'm going to make a rectangular region of about 150 pixels tall, and maybe it doesn't have to perfectly match, but it's nice if it's in the range there. I'm using my roller mouse just to eyeball it a bit. Now it's sitting in the center because it's at x00, so again I could use roller mouse, but I'm also going to just guess here and do maybe minus 150, minus 200 perhaps. Yeah, and then roller mouse from there. So that looks pretty good. The benefit of stimulus coordinate system being 0, 0 is that it's always based about the center, and I'll show you why that's handy coming up here in a second. So we've got a width of 28, a minus x position of minus 223, and a height of 150. That's our region. That's what. So we've got an event type of enter where, I guess this is the what, right? The what, enter. The where, this region. And the do what, or the execute, is down here. Now, we may modify this later to make it a real slider, but simply for motion tracking, you don't necessarily need to if check anything out. So I'll just say if defined equals 0, just standard behavior, do it all the time. What I want to do though is right here I want to affect that slide animation that I defined before, okay? And I want to define this as 0 so it matches the animation. Remember that slide animation was 0 here and 100 here. So I'm going to create little stimulus rectangular regions that match that. And I'm not creating it down the handle again, I'm creating on the back. So I've made an enter rectangular region, a tall skinny ghost rectangle on the left side, and I've said, hey, if you enter that region, that tall skinny ghost rectangle, that stimulus area on that left side, go ahead and set slide to 0. But let's now set slide to 100 if you enter a region of the same shape on the other side. And here's where that center-based coordinate system for stimulus becomes really handy. To do the other side, all I have to do is make sure nothing's selected, because notice how redefine is there if something is selected. I don't want to redefine anything. Redefine, define. I want to make sure it says define because I want to create a new one. So nothing's selected. It does indeed say define. All I have to do to create the other side is remove that minus symbol. The reason it is because the coordinate system for stimulus is based upon the center mass of the object. So we've got the rectangle on the right hand side. The width and the height are the same. That's great. But we do want to change the value of slide. Remember, the slide goes from 0 to 100. So at this right hand edge, go ahead and type 100 and click define. Now, just doing this, we've created a nice region, a hot region from here to there that will basically slice up. It will interpolate this stimulus into 100 slices of enter events. So not only enter 0 and enter 100 work, but just like with animation, now everything in between works too. And we can quickly prove that out in run mode. Were I to come into that hot region, remember we made it about as tall as that rectangle and starting at the left edge and ending at the right edge. So if I'm out here, nothing, but if I move into this area and start moving the mouse, sure enough it tracks with me, and if I move out and jump back in, move out, jump back in. So that is your quick and easy motion tracking, all right, with stimulus. Now you notice this isn't really a slider yet because it's really just tracking motion all the time, and normally sliders have a click and drag. All right, so let's just quickly show that, and it's sort of a combination of button stimulus and motion tracking, but I think it's worth showing in this same video. So let me quickly jump to that real quick, and I'll do it fast because it's sort of a review of other button stimulus, but as I said, I think it's worth showing. So on this top piece that is moving, we want to do a left down on the whole object, and we want to just say slide enable is equal to 1, define. Okay, and then we want to do a left up, just like a button though. Want to make a large rectangular region, and this we're going to make 0, 0 because it's based on this handle now. So we can do that, large region, and we're just going to say if slide enable is equal to 1, go ahead and set it back to 0. So that is setting a flag. Oops, I had that, remember I mentioned define and redefine, I had it selected so it redefined it. Let me just quickly unselect it and go back to left down because I redefined it, so all we have in the list right now is our left up. So I'm going to unselect it, left down on the whole. This one is that left down event I actually overwrote because I did the redefine, so I just want slide enable equal 1. So we have a left down that sets it to 1, left up that sets it to 0. All we do now is simply modify our enters to check for that slide enable. If slide enable is equal to 1, redefine. And if slide enable is equal to 1, and look, I can down arrow tab, up arrow, redefine. And now if you go into edit mode, it does not track unless you first have clicked and dragged on the handle like a real slider. Alright, so that is interpolated stimulus in Altia Design.